Testing the surface roughness of a massive engine block historically required pulling it off the line and physically transporting it to a dedicated metrology lab. Performing laboratory-grade metrology directly on the shop floor is difficult because factory environments present constant variables like vibration, limited space, and dust. Engineers needed a way to bring the lab to the part without sacrificing micron-level precision or data integrity. Measured, introducing the hardware designed to solve this exact physical constraint is the Mitutoyo SurfTest SJ220 Portable Surface Roughness Tester. Because of a compact form factor that physically separates the display from the detector drive unit, operators can execute immediate, on-site measurements on large or awkwardly shaped workpieces. Eliminating the need to move a heavy workpiece reduces machine downtime, accelerating the entire manufacturing and quality control pipeline. To evaluate how this device actually captures and handles data, we are going to trace its signal path. We will follow a single measurement from the exact moment of physical contact with the workpiece all the way through to its integration in an enterprise network. This journey happens in 3 distinct phases. First, the physical acquisition, next, the internal processing, and finally, wireless transmission. Mapping this exact path demonstrates how the SJ220 operates as a connected node for statistical process control, rather than an isolated hand tool. The signal path begins at the microscopic level, the physical interaction between a diamond stylus and the surface of the workpiece. As the 90-degree stylus tip rides over microscopic peaks, the internal coil sensor fluctuates, converting mechanical movements into an analog signal. For softer materials, this 5-micron geometry swaps to a sharper 60-degree 2-micron setup, dropping the measuring force to a lighter 0.75 millinewtons. That ultralight configuration is specifically designed for evaluating easily scratched, soft materials or delicate components, where a standard stylus would leave physical damage. Matching the correct stylus geometry and force to the material is the critical first step to ensuring high-fidelity, distortion-free data acquisition before any electronic processing begins. Moving up from the stylus, that physical signal is propelled by interchangeable mechanical drive units. First, the standard drive unit translates across a flat 16mm plane for typical applications. Next, the retractable drive unit lifts upwards by 1 mm to safely clear a physical obstacle within an automated holding jig. This mechanical retraction allows the detector to safely reset its position without dragging across the part, preventing damage when the tool is integrated into automated measuring equipment. Finally, the transverse tracing drive unit operates by moving laterally, side to side, across a highly compact 5.6 mm length. This lateral axial movement captures data in extremely narrow spaces, like wire electrical discharge machining surfaces and complex crankshafts. By swapping out these drive units, the SJ220 extracts high-precision data from enclosed geometries that would block traditional fixed-access surface testers. Once the analog signal is acquired, it travels out of the drive unit and into the main processing and display module. This module runs on a built-in Ni-metal hydride battery, capable of approximately 1,000 measurements per full charge, ensuring the unit remains mobile on the shop floor without tethering to a wall outlet. The operator interacts with the data through a 2.8-inch TFT color LCD display, which can dynamically switch between portrait and landscape modes, depending on how the instrument is being held. The interface supports modern touch gestures, but crucially, it retains physical front panel buttons, so operators wearing heavy shop gloves can still execute measurements. Internally, the processor calculates primary profiles and roughness parameters. It supports legacy JIS and ASME metrics, but it is specifically updated to comply with the latest ISO 21920:2021 surface texture standard. Evaluating older component prints while simultaneously verifying against the new ISO 21920 rules turns the SJ220 into a highly adaptable bridge for managing tolerances across international supply chains. The final stage of the signal path is transmitting digitally processed data out of the instrument. Standard physical ports include USB Type-C, RS-232C, and proprietary Digimatic output. Complete shop floor integration, however, relies on an optional plug-in module, the U-Wave TIB transmitter. Sitting at the center of the network map, the U-Wave TIB equips the instrument with Bluetooth 5.0. Operators can route a direct wireless data link to a smartphone running the SJ app, displaying surface waveforms locally. Alternatively, data is routed to a PC, instantly auto-generating PDF inspection reports. The ultimate integration feeds these measurements directly into Mitutoyo's centralized database for network-wide quality visualization. Closing this wireless loop removes the SJ220 from isolation, turning a handheld tool into a real-time, automated data collection node for enterprise statistical process control. Tracing a measurement from Stylus to SPC reveals a continuous signal path, linking the physical friction of an engine block directly to an enterprise database. On the front end, interchangeable drive units, styluses, and specialized nosepieces provide the mechanical flexibility to acquire data from nearly any physical geometry. On the back end, the U-Wave wireless ecosystem and MeasureLink software provide the digital flexibility to process and distribute data across the factory floor. Eliminating the need to transport heavy workpieces removes the physical metrology bottleneck. By subsequently automating the data logging process, the SJ220 eliminates human transcription errors.